Okay, so now we start with the chapter 3. Okay, so the chapter 3 is about the multiple integral. So I should share with you the part 1 first. Sorry about that. Okay, so before we look at the contents in multiple integral, so I just want to share with you the formula. So actually, if you look at the on the e-learning, okay, so you go on the first week for our meeting, not first week, before the first week, so the top one. So I attach the formula. Okay, the formula. So this formula means that if we have a physical exam or test, so you will be given the question sheet, right? The question, and also at the back of the question, there are lists of formula provided. Okay, so what is the formulas that can be that we shared during the exam. So you can see if you just download this. So this is the thing that you can see. So we give you the basic. Okay, so this one is the differentiation of some particular single variable function. So you have a cos. So how can you differentiate cos? You get negative sign, and you have a hyperbolic differentiation. Remember in during your engineering maths 1, you have done all these things, right? So we give you all the differentiation for this particular function only for single variable. Okay, and for the integration, similar to the integration for some particular function, so also provided. So you don't need to worry about that. Okay, that is for the physical exam. Okay, and other than that, we also give you the differentiation of inverse function. Remember, we give you, when you are taking the engineering maths 1, you have done all this inverse function, isn't it? And also integration. So they are all given. Okay, and also the trigonometry identities and hyperbolic identities and some of the inverse hyperbolic identities. So I think you have seen this when you have done the engineering maths 1. So you will have the same list of formula. But for engineering maths 2, you have an extra. So there are another formulas provided. So this one specifically for multiple integral. So I'm sure that as for now you have no idea what all these thing means. So but after you done everything's in chapter 3, then I'm sure that you have no problem with that. So we just, maybe you got shocked when you see that these very many curly things here. But it's, when you done the chapter 3, so I'm sure that this okay. Okay, so these are all the formulas given, which means that if you have a physical exam, but now since we are our final exam and our test will be run through online, so meaning that this is not given, but you have to download yourself. So when you have the test and the final exam, then you can refer to that this formula. So you have to download. Okay, download, and every time you do the exercises, so please refer to this formula, so that when you have a test, because you are running out of time, right? You have no much time to just think where you keep all the formulas, then you can just refer to this uh, uh, list of formula. Okay, but you have to remember for test and exam, even though it is open book, but you still cannot discuss with your friends, and also you cannot get your answer from googling or from the internet using the computer or a tablet. Only open book. Okay, just you can refer the notes given to you. Given to you, just then you can refer to the book, just open book, not open website and so on. Okay, alright, so that is about the formula. So please download this one because you need this for chapter 3. Alright, and also for chapter 2 as well for differentiation. Okay, so that is for the e-learning. Okay, so now we go to our lesson. So um in the objective is you want to integrate, right? But then there are some steps that you have to provide. You need again the sketching. Yeah, you need, this is compulsory. It is must. If you cannot sketch the region of integration, then you cannot determine the limit of integration. So when you cannot determine the limit of integration, so you cannot solve the integration. Okay, so that is why I tell you here, the sketching, you need the sketching again. The sketching of the 2D and 3D. Okay, why we need that? So you will see later. Okay, and then after you done sketching, you have to evaluate the double integral. You have to integrate. Okay, so and at the end of after you know how to integrate, so we want to apply. So we want to know how can we implement the technique that you have learned in the real life problems. So since there are very many applications out there, so we just specify on some real problem, which are how can we find the area, volume, mass, center of mass, and moment using multiple integral. So that is our objective for chapter 3. Okay, so I don't want to speak on this, so you can read by your own. Okay, so to explain this, so we just recall on the single integral. Okay, so last time your teacher, your lecturers already explained to you. I mean, this one should be before you came to UTM. You have the matriculation, and maybe your teachers, your lecturer has told you that the application of the integration is, let's say you are given, so this is for single variable function with respect to x. Okay, so x from, let's say, 1 to 2. Okay, this is called as integrand. The function inside the integration is called integrand. Okay, and dx here is called as order of integration. Order of integration. How can you spell integration? Integration. And here these are because we have a definite integral, so you should have the limit. So then your final answer should be constant, a value. Okay, when you have a limit, then your final answer should be a value. But if you have indefinite integral, which means that you don't have the limit are not given, so your answer is not a value but an expression. Okay, you have an expression in terms of expression, mathematical expression in terms of x. Okay, for example, okay, I give you a simple integrand which is x dx. So what is the answer for indefinite integral? You have x squared over 2, and you put the plus c because you should have, because this one no limit, so you should put the constant here. Okay, the constant here, it can be 0 or it can be any a number. How can you know that? Then you have to have the initial value, for example. But for this chapter 3, so we will focus on the definite integral, where you must be able to obtain the limit of the integration. So your final answer is a number, is a value, so that you can elaborate, so you can explain what is the application. I mean, okay, let's say I give you definite integral. So you have okay, x squared dx from 1 to 2. So how can you obtain the integration for this single variable function? So you have x cubed over 3. Okay, and then you put the limit x from 1 to x to 2. Okay, so now you replace, so you put what we call that, the upper limit here. So 2, you substitute into the x, so you got 2 cube over 3 minus 1 cube over 3, and this will give you 8 minus 1 over 3, and the answer is 7 over 3. So you will get a value here when you have the limit, or we call this as definite integral. So how can you elaborate this value? Or I would say, what is the application? What is the actually you are doing? So you have to understand the thing, why you do this integration. So what is the application? So I would say that, what is the application? Why is 7 over 3 actually? Okay, so 7 over 3 here is a value. Since we know that the application of single variable from x1 to 2 is actually you are compute the area under the curve, right? So let's say your curve is quadratic. So this is y, and this is x. So now this is your x equal to 1, and this one is x equal to 2. So the 7 over 3 here is actually the value, the area, okay, the area under the curve of x squared. So this is application. You can determine the area under or below the curve for if you are given single integration for single variable function. Single means just you need to integrate just once. Okay, single. So your order also there is only x. Okay, now by using this ideology, your understanding on single variable function, so how can you extend this into double integral? Okay, why we call that double, and why you need double here? So now so let's say so why we call that double? So now we on the first chapter you already done the multivariable function. So let's start with the double integral. Two variable functions. So you have, let's say, x squared plus y squared. So your function, your integrand here in terms of x and y, or you can have x and only y, but we define the function even though there is only x squared plus 1, for example, but because we define the function given is in two variable functions, so you have to bear in mind this is about two variable function. Okay, that's why if you realize when you have the sum when you do some exercises on the past year question, we always start with the given that, okay, or suppose that f, you can see this one, so meaning that we define that. Okay, so we introduce to you that the function that we have is two variable function, so that it's must. So we will make sure for every time you have test, so we will define that, because I got some question from your friends before this. They ask me that how can I know that I have single variable function or I have two variable function, even though the function given is just single x? Then you don't need to worry, we will define this first. Okay, so now how can you integrate? Let's say you want to integrate this function, okay, x squared plus 1. So then, as a normal process, you have to put the integrand inside the integration, right? So you have x squared plus 1. Okay, but now because of your function is now in terms of x and y, you have to integrate respect to x and integrate respect to x. So who comes first? Who comes first? So you have to look at from your order of integration. So what is order of integration? So the x. Now since you have two variable function, so your order is no longer just dx. You have another member there, which is dy as well. So now your order of integration is supposed to be, you have to add another one, dx, and now you have dy. And similarly, your curly thing here, you have to add one more curly thing. Okay, so that's why we call this as a double integral. If you just have single, so single integral, but you have only the x. Okay. But now because we define the function is two variable function, so when you want to integrate that particular function, then you have to deal with double integral, and your order, double integral, and your order, you should have extra order. Okay, so maybe you might wonder, should I put dy first or should I put the x first? So you can do either way. Okay, so now if you have this order of integration, so you can also have x squared plus 1 dy dx. Okay, so then how can you determine the limit? So I will teach you how can you determine the limit. So as for now, I just want to introduce you about the double integral. So double integral means you have two curly things, and your order here, there are two terms, x and for y. Okay, about the order, so we call this as order. So what is the order that you are using? Dx dy. And this one, what is the order that you are using? Dy dx. So how can you determine this? So I will teach you later. Okay. So that is a double integral. So similarly, using the idea, so we extend the idea for triple integral. Triple, which means 3. Now you have 3 curly things. So your functions now about the triple integration, your function now is, you define your function is, let's say you have x squared, y squared, and z squared. So you will see that we define the function is in this form. We have 3 variable function, even though you can have 3 of them, or you can have just 2 of them. Also possible. Okay. So how about your integrand? So let's say I'm using this example. So x squared plus y squared. And now your order, you have to add another term. Now belongs to z. So dx, dy, dz. How can we change? Yes, of course you can. So for two variable function, or for double integral, you have only 2 options, this order or this order. But for this one, how many options that you must have? For your information, this one you have 6 options. 6 options. You have dx dy dz, or dx dz dy, or you have dy dx dz, and so on. You have 6 options. But for you to evaluate the double integral, you have to choose only one. You don't need to waste your time to try for all the orders of integration. It is wasting your time. Okay, but how can you know which option that you have to use for this triple integral? Then don't worry, there is a way to determine that. Okay, but you have to follow the step one by one. Okay, so that is a double integral. So this one just a revision, so you can read your own important formula. So as I mentioned just now, you have to refer to the formula provided here. Okay, double integral. So for this, I will explain to the next video about the integrand for double integral, because in general, so the double integral is defined as f x y dA r. Okay, so I will explain to you what is the r main and what is the dA here. So but now I want to stress out the function or the integrand here. So as I mentioned before, so the possible function that can be is only whether you have a constant. Okay, it can be, so for this, so the function here, it can be constant, let's say 2, 10, or 10x, or 10y, or 10x plus y, which, or the combination of x and y, or just single x or single y. But you cannot have z, because z is actually the outcome of this function. So the possible function can be put in this double integral is only expression contains the x or the y, or the combination of x and y, or constant. Okay, but there is no sec.